Hi everyone and welcome to this tutorial. My name is Masoud Pourghavam and I'm the student of mechanical engineering. This is the introductory video to introduce you the ABAQUS interface and how to normally use it for basic finite element models. So let's get started. When you first open ABAQUS, this is the 2016 version as you can see in the left corner. When you get started, you will be greeted with the source file system screen for standard finite element modeling, and we will use the standard explicit model option. So as a typical program, we have these options up here. There are different modules here and you can also access them from tree view. So let's go to the first module and see what's going on. As you can see, there are many tools here that you can use to create your own 3D model, but since ABAQUS is a CAE software and it is not made for 3D model design, I prefer to use a computer-aided design software like SolidWorks. So let's go to SolidWorks and to design our 3D model. Hit new from up here and double click on part to enter the part environment of SolidWorks. Let's go to sketch. But before we start, I have to say that if you are interested in learning SolidWorks, you can watch the SolidWorks tutorial videos on our channel. As you can see on the screen, there are practice design videos of an electric motor and a screwdriver, a desk lamp, and a shock absorber. So I will put the links in the description below and you can watch that videos anytime that you want. All right, go to front plane and draw a rectangle with a length of 4000 millimeters. And here give it a dimension of 500 mm. Okay, I'll go to features tab and select extrude bus and give it depth of 300 mm and select OK. And that's our model. This is the model which we need, and I go to file and save it as a step file and select the folder and click on save. Okay, this is our model. So let's go to the ABAQUS and import the model to ABAQUS. I select part and as you can see here, you can change a lot of settings. I changed the name of my part to solid planet, and in part attributes you can change some settings, and I will change the scale to 0.001. So we imported the part and we don't need to create a part anymore. So we can skip the first module and go to property. So let's assign a section, select your part and hit done. And in edit section assignment, you can add a material. And as you can see here, you can add a lot of properties, general, mechanical, thermal, which is comprised of heat generation and conductivity, and electrical and magnetic properties, and other properties. So I go to mechanical, elasticity, and give a Young's modulus of 30E9 and a Poisson's ratio of 0.3. So click on OK, and as you can see, when the color of our part is changed, it means that we assigned a material to our part. In mesh module, go to global seeds and give an approximate global size of 0.05. Alright, click on this tool to apply the mesh to your part and go to mesh controls, and as you can see, you can change the element shape, and in element type you can change the element library, geometric order, and other settings. Okay, the next module is assembly, and to continue we have to create an instance from our model. Now just go to step and create a step for your project. Very well. In load section, first of all, I want to apply a force to my model, As you can see here, you can apply different types of loads such as moment, pressure, shell edge load, surface traction, pipe pressure, body force, line load, gravity, and other types of loads. So I select concentrated force and I select this point and click on done. So here, let's change the parameter of CF1 to see what happens. And as you can see, here, CF1 represents the X direction, and if we put a minus sign behind its value, the direction of the force will be reversed. So I give a parameter of 2000 newtons to CF2, which represents the Y direction. But as I want its direction to be down, so I put a minus behind its value. And it is clear that CF3 represents the direction of z-axis. Alright, so let's apply a concentrated force to the model just like we did before and give a value of minus 2000 newtons. Alright, so now I want to create boundary conditions for my model. There are different types of boundary conditions and I select the first one. So I rotate the model to select the face I want to fix. In boundary condition tab, I select Incaster to limit the movement of my face in all directions. Alright, cool. So it is almost done and we just need to create a job. Click on continue and here you can give a description to your job. And here when you open the job manager, you can see the name, model, type and status of your project. Okay, just submit the job and it says that job files already exist for job 1. Click on OK and wait a few seconds. I have to say that if you want to see all the steps of process, you can click on monitor. So I click on that and as you can see, the job is submitted on August 30 and the analysis input file processor is started. So and it's done. As you can see, the number 1 here means that the simulation is completed. So you can close the monitor tab, but I have to say that if you want to see the warnings and errors, you can see that from here. So just click on here to see the results of simulation. When you click on this option, you can see the deformed model, which stresses have not yet been specified on the model. And let me just move the model to the center of the screen. And if you click on this option, you can see the amount of stress. As you can see, the von Mises stresses are displayed from the highest to lowest value in the table. And you can see other views and other options from here, but I just go to animation to see how the model is deformed. And its speed is so fast, so I reduce the speed and click on apply to see how it looks. Very well. So you may need to obtain the maximum stress in this critical area of the model, but since the load was applied as a concentrated force, so the maximum stress was created at the same points. To solve this problem, you can select the nodes and remove them. So I'm gonna do that, and as you can see, when you do that, you can see that now the maximum stress is applied to the fixed end of the model. Okay, this tutorial video about basics of Abacus is over, and I hope this tutorial was useful for you and you enjoyed watching it. Please leave your comments and tell me your opinion about this tutorial. It will definitely help me to improve my work. Thank you. Goodbye.